I am. Yep, you have the right person. All right, I think we're going to get started here. All right, well, I want to thank everyone for coming today and hear my presentation. And I want to thank also Jason for drawing in a crowd for me. So hopefully I can share some nuggets of information. Today, I want to share a little bit about just what I've learned over the past couple years around. I've been in information security now doing this for about 12 years. And over the past probably 2 years, I've realized that there's some changes of things that just need to happen around the big data analytics, ways that we can improve and get better. And I'm looking at things that I've done over the past probably 10, 12 years. Has anybody in here written a script or a file or anything? Does anybody here have probably hundreds of those packed away across probably 10 different computers and you wish that you could find it whenever you need? That's same for me. So I've done so many different things, used so many tools over the years that I wish I had a repository, a place where I could go back and leverage and continue to build on that information. So that's kind of what I want to share today with everyone, are some opportunities where we can all get better and do that. So a little bit about me. My job title, I'm an information security architect. That's really a fancy way of saying that 80% of my job is doing PowerPoint. And on the days that I feel dangerous, I'll crack open Excel. So that's, but in my spare time, security is a hobby as well. So when I go home, spend time with family, then at night, my boss always jokes that I don't sleep because I love doing security research. I love reading about technology, I'm on Twitter. You probably don't know of me as much, but I probably know of you. I'm more of a lurker doing that. And you'll see that Twitter is crossed off of the top. So if you see me in the brochure, it's _Ryan_Elkins. Well, for years, I have wanted the handle Ryan Elkins. It has driven me crazy that you've had to do underscores and all these fancy. So I thought, I'm gonna own my domain. I'm gonna take this back. So I looked up who had the handle a couple weeks ago, searched them out. They didn't have direct messages, so I figured out exactly the kind of location of the country, did my Google hacking, spotted, I think this is the person who it is through white pages, started searching all of his followers from Twitter over on Facebook to try to identify him on Facebook, send him a direct message, thinking, man, what's this going to cost? It's going to cost me $100 to get my handle. It's going to cost what's the going rate? And I ask, and he offers it up to me. So it was pretty awesome. So in a way, giving back. If anybody after this conference wants the_Ryan_Elkins, it's up for grabs. So let's get to the information. I want to start with thank yous as well. So part of being in information security is learning from everyone else. That's why we're here. That's why I go to DerbyCon year over year to touch base with all of the people, all of the experts that I've crossed paths with. It's awesome to learn from everyone. And I'm not an expert in all of the things that I'm going to show you today, but I feel that I've been able to learn and gain knowledge from tons of different experts across the industry where I can start to piece that together. And that's what I love about security. That's why I get so excited about the job. Is we're in this to solve puzzles, solve the world's most challenging problems. We're hit at a global scale every single day. It's exciting. It's powerful, the things that we can do. That's why I love it. But I also love that we don't have to learn everything ourselves. We can pull the information. We have an open community where there's so much information out there. It's just how can we best leverage it? How can we use it? And how can we apply it effectively? This quote is something that's really resonated with me. And this was a presentation by David Rowan from Wired, but he mentions things will never move this slowly again. And this was a couple years ago said, and that rings so true. We hear so much in our industry around just burnout and how fast, and we're overwhelmed and we don't have enough staff. We don't have enough resources. How do we address this? How do we do with it? How do we do this? And that's a problem. It's systemic. It's everywhere you go. You will never not have enough work in your hopper to finish the job. You should always be busy, always doing this, but we need to change how we work. How can we evolve so we are not just following manual processes and being those bottlenecks? We have to evolve because the world is evolving around us, and we have to move either faster than them or at least move with them. This is kind of my view of the world from a security perspective. So you have, I call it the bolt-on security. This is the hundreds of vendors. It's the eye charts where we're going to sell you all these things that you put this on your network and you're secure. We'll fix it. We're 100% good. You're guaranteed. These are all the guarantees that you buy, all the shelfware that we spent millions of dollars on over the past decade, all on your on-premise network, tied together, offering you protection. And that's not where the world's headed. And I say that's not where the world's headed. It's already long past. We're 5 years behind already in terms of doing this. But you hear a lot of this concept, embedded security, security by design. This is baking security in. It's decentralizing the model. It's using, as Beeson would call it, the security champions, getting decentralizing that information, providing the standards, the guidance, the controls, enabling teams, empowering teams that are not in security functions to make those security requirements, bake those into their solutions. If we don't, there's going to be these spheres of applications running everywhere, and they can either have security or they don't have to, but it's going to happen one way or another. And if we stick with this bolt-on security model, we're going to fail, we're not going to scale, and it's going to be a false sense of security, as Jason previously kind of spoke about on that top. Or in the prior talk, that's not where I want to be. I signed up to be in security to be on a winning team, to win, to stay ahead of the adversaries, and everything that I want to put together to teach us, we want to be on that winning side. So when you take those spheres of security now, today's world, it's no longer you're talking from your on-premise building to the cloud. You are talking hybrid multi-cloud, where you're going on-premise, you're going to Amazon Web Services, you're going to Google, you're going to Azure, Office 365, Heroku, Salesforce, and then hundreds of third-party SaaS providers that perform niche operations for your company. And not only that, but those communications now are not happening through a centralized, visible corridor where you would typically apply your logs or your span ports and your CASBs and all this. These connections need to happen cloud to cloud across, in addition to your data center. And the kicker that's not even on this slide are your users. You talk about edge computing. We hear more and more. There is no, you want to put them on the internet, allow your services, and you want to be secure. But your mobile workforce now no longer is going to be on that secured network and your facility. You add users to your, and this is a huge, massive spider web that we have to secure. And we are losing in many fronts on this, and we need to find solutions. How many of your security programs feel like this? Where you have everybody around you, the biggest buzzwords right now, robotic process automation. We need to get faster. We want to do all infrastructure as code. When you write your code, you need to write it, you put it in GitHub, you do a pull request that goes through your CI/CD pipeline, and you are deployed in seconds. That's how our business wants to run. That's the speed we have to run to stay ahead of our competitors. You have information security in there, be in the manual. We need to meet with here. It's the Ryan and so show. We need to make sure that's not okay. That's not how we need to operate. We need to be data-driven, risk-driven. These decisions should not be in our heads on making, when we make a decision based on risk, when you go to your security advisor or somebody and they're making that, they're really doing a data-driven risk calculation, or they're just guessing one or the other. They may not admit, but those thought processes need to be put to code, codified. There is no reason we be that manual talking point in that step. We have to move, because if not, they're just going to cut us out. They're not going to wait on that barrier forever, and we don't have time. We have to build that in, and we start thinking about how can we automate those decisions. And at the same time, we talk about how exhausted we are and how much we're burnt out. Let's automate these things. Let's not repeat the same thing twice. If you have to make the same decision, or you ask the same questions over and over, that's crazy. That's not sustainable for anybody, and nobody wants to do that. So let's start with that together. I know when you think about architecture objectives and how to secure a system, typically you ask the same things. You ask, do you have malware protection? Do you have a firewall? Do you have logging? You ask these same things over and over. Let's just write that down, hand it to your development team, and say, do these things. If you can't do it, talk to us. We'll figure out. We have a streamlined risk exception process. We'll pass you through, move along. And then the risk can be overtaken by the business. They can be signed off. We've effectively quantified it, and we haven't slowed them down. That's where we need to get to, and we need to be effective. This has resonated with me since I've read it, and it's resonated with me because I feel it is completely true, completely accurate. And through actuarial data, so insurance actuaries, what they do is they measure risk. You think of insurance companies, they will charge you this cost and cover you for the cost of floods, tornadoes, hurricanes, water, fire, cybersecurity. Their business model revolves around effective risk decisions based on your security posture, on your decisions. And we are failing as a security industry in doing this. It's embarrassing that our insurance companies, the analysts, the scientists, the statisticians that know nothing about information security can tell you, your organization, you have this percentage chance of getting breached versus this. And you know who the CISOs are going to listen to? They're going to listen to the insurance companies. They're not going to listen to you as an engineer saying, I need this tool, this capability, or this vendor. These are going to be analytic, data-driven, across industry information that is going to have extensive value. And it's sad that we can't display that effectively as an industry. We need to get better. And that's not saying that we're failing, but we need to be partners with the insurance industries, the actuaries. We need to learn, what are they doing that we're missing? What are they doing differently? Maybe we need to bring math back into security. Maybe we need to bring these scientific processes. Something is working for them that's not working for us. What is it? So there's really three major shifts that I see in mass adoption, and this is all driven by data and analytics. And I work at Lilly Pharmaceuticals, so I get to work with our R&D department pretty extensively, and it's exciting. The reason because I focus on cloud security there. And all the trailblazing projects, everything related is big data, is analytics. I always thought it was a big deal to say that we can process 100 gigabytes through our SIM of security monitoring, and we can run a query in about 45 minutes and tell you if somebody's doing something wrong. That's not great. I'm talking to these scientists. They are processing 7 petabytes of data, and they need to move faster, and they need to do queries in real time because they are finding cures to causes like cancer. And these are the big deal things that, if they're able to do this at this scale, surely my need to search 100 gigabytes of logs is capable, is possible, and should be automated. What are we missing? So I started asking questions. I started learning from them. I want to learn. So the first thing that's happening across the industry, and it's something that every one of us can get into because it's extremely exciting, is democratized accessibility of data. There are tons and tons of data sets out there freely available that we have access to in the capabilities. The problem are that these data sets are terabytes, petabytes in size, freely available, freely searchable. We can use these, but we're just on the front of learning how to actually search these, how to apply this and do. But if I had to recommend, how do you get started? How do you start learning? These are the key go-tos that I would say. Kaggle is awesome. There's so many data sets that people just submit and do. You can just start learning, talking. It's an entire area there. The AWS Public Dataset Program, S3 buckets have tons of data, and the cool thing about that is since it's all stored in the same way, you can access it the same set. So if it's one set of data on S3 across, you just need to kind of understand the schemas, the formats, and you can tap into that. And one of the areas that I just learned about 2 weeks ago is Common Crawl, and I think it's, 25 billion web pages crawled. So think Google search. But Google search, you're only getting websites back and doing. What if you could search the actual HTML? You could search the script tags. If you can look for threat indicators, if you can look for cross-site, just think about all the endless things we as either red teamers or blue teamers or hackers or adversaries could take advantage of if we only knew how to search this data. The next part is data gravity. We have to move closer to the data. It's now unrealistic to move these data sets. Once they land somewhere, we have to build the compute around it. And that's a big driver to why there's so much hybrid cloud and why you have to use Amazon Web Services and your company has to use Google and Azure. There are key capabilities being advanced on, whether it's machine learning or natural language processing or advanced analytics, that maybe from a security perspective, you don't see the value, but the business, when you're looking and putting these together, these are the groundbreaking things that are going to put your company advantage. They're going to drive. That's the business reason. We have to get around it. We have to rally with them, and we have to help them be able to secure and build, operate, and compute, and move that closer to these data sets because data is gravity, and it's not moving. So here, the third part is it's financially viable now. I'm going to show you in a few minutes a demonstration. I don't have internet access, so we're going to kind of pretend on a couple clicks on this, but basically in about 3 hours one evening, I was able to sit at home thinking about what would be really cool to show and do. Well, using these data sets that are free, Rapid7 has Project Sonar. I know HT Moore created quite a few years back. And and it's out there. And what it does is it just searches crawls the entire internet, gets footprints, all the different services. He has all of the DNS into data sets sitting on S3 and Amazon. So who here does bug bounties? Does anybody do bug bounties or anything like that? Application security. Who does reconnaissance? All right. Well, I hate being noisy, so I don't like to plug away, brute force. I've never been a big fan of brute forcing anything. So some of these tools, if you use AMAS, if you've used Durabuster, you're brute forcing directories, trying to figure out what's there, what subdirectories. Why do that when we have Wallace running every night, searching the entire internet, collecting that data for us? We don't have to be noisy anymore. We don't have to brute force. We don't have to guess. All we have to do is search their data set that's really available, wide open. And so I sat in about 3 hours, put something together, and there's about 2.9 billion objects in that data set of just DNS all records. And you can search that for any domain that you want. And it takes about 2 to 5 seconds. And it cost me about 2 to 4 cents. And so I don't have to hardly spend any money, and I have the capabilities that 5 years ago we were investing millions of dollars in compute infrastructure and doing. And it's just because I've learned from other people. I figured out how some people are doing this. I put it together, and I've done it. And I'm going to share this at the completion of this talk. All of this that I talked about is going to be out on GitHub, fully available, so you can pull it, you can learn from it. And that's what I want, is just pull these examples, see, figure out how can I apply this to my business, to what I'm doing. So let's get started. And this is another quote that I like, and we're not going to get in the weeds on machine learning and all this, but this is true. I missed a lot of the early hacker scene. I love reading about it. The CDC book that just came out is awesome. It's a good read. There's so much to learn, but we're on the forefront. We're on the groundbreaking. These things that we do today are going to be the things that our kids in the next generation of security are going to talk about, and we are leading this way. Let's pave it. Let's do some cool stuff. So the first thing that I did at work was, as we moved our data sets, one of the things was, well, Ryan, we feel like we're going to have to move our Jupyter notebooks to the cloud. And I'm thinking, Jupyter notebook, I've never heard of it, but I guess I'm picturing like this really rugged laptop that could probably survive on Jupyter. That's what I'm thinking. So I'm going through, while you're using our standard image, what are you doing about patch management? You're like, no, Ryan, no. This is a software-based web page driven. So what it is it basically, let me see if the next slide has a little more detail. Yeah. So Jupyter notebooks are actually, you picture OneNote, but it runs in a web page. So you can host it, you can run it locally, you can do, and it supports over 40 programming languages now. The primaries being uses you usually hear Python and R, heavily used by the scientific computing community, but so I continue to ask questions, and so you want to move this to the cloud. Well, tell me a little bit more, like, and the guy's saying, well, it's really not that big a deal. It's probably not that much of a security risk. All right, so I know that your on-premise infrastructure, you need to move because 1,000 distributed cores isn't enough. This is your interface into it. Tell me more. So what's it do? Well, you can write code. You can write Python against it. So you're pretty much self-contained, limited. All right, tell me more. Do you have access to the operating systems behind it, knowing that you want to go from 1,000 core limitations to unlimited compute in Amazon? Well, yeah, actually we can run operating system commands. You can do whatever you can through a Python interface. I'm thinking, all right, this probably isn't a security big deal thing, but go on. I've just confirmed that you have full underlying host capabilities to do whatever you want, tied to our network, running Python on top. No big deal. Tell me more. And so we go on, and basically it ends up in a conversation. Well, I think I need access to this to dig in a little bit more, if you know what I mean. So we secured it and got it all working. But it's crazy that I did not ever hear about Jupyter notebooks in 12 years of security until the past year, and I have been missing out. It is the coolest thing ever. If you're trying to write code or scripts and I'm going to show you some demos on why it's so neat. But it's something that I recommend, even if you're not in a technical role, the things that you can show to demonstrate of just so little lines of code, just learning a few different things can put you front and center of answering some of the toughest questions that you want. So this is what a typical data scientist library looks like. If you had to pick any tools they're pretty much, everything pretty much revolves around matplotlib and NumPy. So that's doing mathematical calculations, data analytics. It can do it at scale. You have some of the leading scientists writing this, so they're absolutely optimizing it. This runs fast. And then you have some key things where you can do cool visualizations with Bokeh, and they're Seaborn, and those are some of the ways that you can actually visualize data. And then Dask on the corner. So what a lot of Jupyter does, some of the limitations are it runs everything in memory. So it's extremely fast, but you're memory constrained. So let's say I'm running it from my 16 gig laptop of memory, then I'm memory constrained. So I want to, maybe I'm doing a process in a big data set. Well, you can use the Dask library, distribute that across as many compute as you want. So I was going to actually demonstrate an example using Dask, but I couldn't because the space on my laptop is actually less than the amount of memory I have. So I couldn't do I could have done it, but either way, it gives you the ability to leverage distributed computing in just a single library that you can run from your local laptop. So we're going to go ahead and jump into, and who here likes to tell stories? Everybody in security likes to tell stories. That's why we come to DerbyCon, other places. Everywhere you go, I was sitting at Zoop and I heard about 10 different stories around me, all of security related, but different things. So we love to tell stories, but we need to get better at it. We need to say the things that are going to give value to our executives, to our leadership, to our stakeholders, our shareholders. These are two neat visualizations that have been done out of these libraries. These were actually done about 5 or 6 years ago. These are dependency trees of Python libraries. So if you take Python compute, everything mapped together, that's what that looks like in that ecosystem. But to be able to tell a story visualization, that helps us. But what it really comes down to, what I found that helps the most of getting value out of everything we do is going to our 5th grade science class. It's the scientific method that we thought we would never use in real life ever until I've started to apply this and think through information security on where have we failed, where have we missed the boat. Well, if you look, the scientific method that we all learned about, it's been around since the 17th century. Start by asking a question. What do we want to solve? Before you go buy that piece of software, talk to that vendor, think about what's the question, what are we trying to solve? And then let's do a little background research on our own, see if we're on the right path. And then you construct a hypothesis. Everybody that I work with in research and development, the scientists, the statisticians, everything is my hypothesis is this. I think this is going to happen. This is my prediction. And then they continue to build those test cases. They experiment. They work through it. And if it doesn't match their hypothesis, that's not work lost. That's not throwaway work. That is investment for the future ideas, future benefit that they share with other scientists, other people. We don't do enough of that in security. We think about, well, we've heard that this is going to stop these attacks, these intruders. Let's do this. But let's think about the why. Let's start walking through this scientific method. And then once you get there, a lot of times we stop at, all right, this seems to work, but have we actually analyzed the data? Have we processed it? And then you build the visualizations, you confirm your hypothesis, or you show that it needs more value. And then the last thing is communicate the results. We are bad at communicating as security professionals. We need to get better, and that's the follow-through. That's the commitment. That's showing that we bought this product, this tool, this capability, made this investment. Here's why it works, here's how it works, and here's how you use it. And hopefully that leveraging that communicate results. I don't like paper. I would say this communicate results should be codified. It should be, I can inject this into your code pipeline. I can get this into your process. You are baking, you are doing that embedded security. You walk through this, you show that value, you will win over teams every single time and be much more successful. So it starts with asking the right question. So as we jump into some demos here, I want to start off with, there's 3 different questions that one solution solves. It's just, we have to think through how do we say those same things. So the first one is, I'm an adversary. How can I perform passive reconnaissance without actually touching the target? I don't want to know that I'm even interested. I want to just show up under the radar. I don't even want to be on the radar. So that's one question. And then if you talk to your CISO, the CISO may want to know, what does our external attack surface look like? What do we look like to our adversaries, our red teams? Same type of question, but different intent. And then you talk to your CEO, they want to know, what does our company look like to the outside world? What are our shareholders looking at? What are investors looking at? What are our cyber insurers looking at from a hygiene standpoint? So what I didn't realize is security risk advisors are actually sitting out of the door on one of the vendors. So I'm talking a lot about not buying into vendors and different things, but they actually part of this that I'm going to demonstrate here is one of their guys wrote a really cool blog on setting up using AWS services. And you basically set up an API gateway. So it's an API that runs, and it uses two services called Athena and Glue. And Athena is it's like SQL language where you can search S3, big data, all of these data sets that are out there in the internet, you can write queries against. And then Glue actually is more the index, the hive, where you can then do it so you don't have to over and over search that data set every single time. So those are two key things, and that's kind of the bread and butter of getting a lot of this to work, is just using the tools right properly, where because of this work that they've done, that's why I'm able to run queries against large, massive data sets for pennies on the dollar and in very short periods of time. So I'm going to jump on over. This is what I was trying to figure out before my presentation is I can't see the screen from standing here, so I don't know if the sound guys are going to like it, but I might walk over to my screen. I'm going to switch out. All right, they're giving me the thumbs up, so we're going to do some quick switching here, and we're just going to walk through the examples and kind of demonstrate what we can do. But let me go back here. Are you able to see? We'll show these first, actually, and I'll show the code. But what you're seeing on the screen here are this is what I can run in about 2 to 4 seconds against whatever domain name that I want using the Qualys, the Sonar, Project Sonar DNS records. So I can produce a heat map, all of this end to end. It takes about 30 seconds. That's because it takes a couple seconds for the S3 object to download, so I have a sleep for 30 seconds in my code. So that's probably really the only reason. But this is a heat map of, I believe this is apple.com. So this, I can run completely passive, not touching Apple whatsoever, anything of their system, purely using open data sets. I can run this and have this result fully generated under 30 seconds for whatever domain I want across the internet. And you show this to your executives. This is what our external presence looks like of all of our websites, where it's hosted based on IP, lat, longitude, and doing. So it's pretty neat. And to be able to go through there, I mean, just looking at some of the biggest tech companies in the world, does anybody have any ideas? What's this look like? This is Facebook, what they look like from an external perspective, facebook.com, and all subdomains underneath. This one, yeah, I think this one's Microsoft. I believe they have 178,000 A records underneath star.microsoft.com. This is their heat map of what their external presence looks like. And then here, I thought this one was pretty interesting, Amazon. So I'm going to flip back and forth a couple times, but they actually don't look much different than Microsoft at all. So I feel like from a cloud provider standpoint, they're following very similar thought process, but you see that map barely change. This is Alibaba Cloud. I thought, well, let's try some other ones from non-US based companies, and so this one kind of demonstrates that in their layout. Anybody have any guesses to what this is? DerbyCon.com. If you noticed, you could get an early peek at the CTS scoreboard. That's been out there for a little while now. So if you were wondering what it looked like, I thought it'd be pretty cool to get myself registered ahead of time on there. It was only a public view. I think Scott White down there and Rob Simon, they're doing a great job, and they locked it down properly. But this is just a quick example of what you can do, all under microseconds, not touching anybody's company and not doing anything, but just all of the freely public information. You start thinking this from an adversarial perspective. I have this information. I have the data sets. I have the latitude, longitudes. I have the C names. If you're doing bug bounties or enumeration, or you're just trying to profile a company, you spend hours and hours trying to enumerate the domains and guess what do they have. And you're doing Google hacking. You're doing all these sources, certificate transparency checks. Why not just use this? And you have, I think Microsoft, I said 178,000. So pretty neat. But you can start applying this concept to other things. If anybody's ever run a certificate transparency report, anytime you have a publicly exposed certificate that you get from a public company, it's in a transparency report. So you can run it. You can figure out what does my company look like doing. One of the guys, Justin Bollinger, actually wrote a script that will parse the data, but I took it a step further and then started to use the GeoMines IP mapping just to do some heat maps for examples. Some program value. So we've talked a lot about IP mapping. I don't want it to all be about heat maps, but this is an area that I use internally, whereas we build application security programs. It doesn't have to be big data sets that you can use these concepts with. This is just a snapshot of the spreadsheet that I can maintain from a program standpoint. I want to look at my current, where I'm at today. I want to look at the future. I save that spreadsheet in one location, always point my code to it, and with the click of a go, I have updated metrics that I can publish out, save it, publish directly to an HTML site, a dashboard, a screen, a monitor in your area of how the program's doing, how it's maturing. You think about being able to just do that with every one of your spreadsheets that you maintain manually, or you do these transforms. Let's just do it by a couple lines of code, and you can build really neat programs where you're demonstrating out day-to-day continuous value to your executives, to your leadership. You can build justification on why you may need some different things. So here's another cool one that I thought was just kind of neat. And this is the intent of this is really just to get your mind going, thinking about all the different things you could leverage these for. So if you think about why are we so busy over the holidays, your patch management team might be asking that, or at what times do we need to increase our staffing, the security manager, or the CISO again, why do our vulnerability counts always increase? Well, I thought let's look at the CV database where you can actually download the past 20 years of all the CVs published. And let's run some analytics off of this. So you can see from 1999 to 2019, I mean, how much year over year that the CVs have been published. These are your vulnerabilities and products that you typically would get patches for and receive. Now, it doesn't mean that this number of vulnerabilities have always existed, but these are the known vulnerabilities. So more and more are being discovered, more and more companies are recognizing it, leveraging CV, but you can just see the year over year growth of this is becoming a bigger deal. This is why we have to year over year spend more on patch management, or it's a bigger deal, or why are trends. These are the stories that we need to tell behind the data, the value, and it just continually expands over the program. This is what we've missed as an industry, I feel like, at least I have personally, over the past 10 years that I could have been tapping into, telling this story over and over again. So there's the challenges to solve. I think this helps with our competition for talent. First off, it increases it because if you learn this, you become more valuable to the industry. But also, we have constant, I mean, CISO tenure is 24 to 48 months across companies. It's hard to build a mature program when your leadership is leaving continually. And then you also look at how many times that you've re-kickstarted the same process. We're doing this new technology. Why haven't we been building year over year on top of this? How do we lose this continuity? If you start doing with the Jupyter notebooks, codifying what you're doing, building these metrics, that makes it a lot easier that you don't take steps back every single time you lose key resources, because that knowledge is there, it's continuous, and then your new team members can just continue to build on that and iterate. The next are the program continuity, which I just hit on based on that. The program continuity is we don't want to lose knowledge every single time somebody good from our teams lose or leave. Let's have them start to work, publish their information. Let's drive metrics. Let's be a data-driven program. And then the third one is the continuous risk measurement. We need to do everything based on risk. That's how our business does. That's how they operate. There is no reason now that we should just say no for no. We have to be driven based on risk. And then sometimes risks are worth taking. There's always business value. There's money to be made. We don't have a security program if the business isn't making money. We have to weigh that, and we work with the business, partner with them, and learn what's the value there, where is that, and let's work and partner together with them. And I'm not actually done with the presentation. Sorry, I hope it's digging in. But I thought since I have to do a couple screen swaps for this, I'm gonna show you a couple of demos now of what all these tools look like, because it's pretty fascinating just to see how limited effort you have to put in to get this extensive value. All right, I'm gonna walk over here real fast. This will be interesting to point through. So this is the example on the this is the Google Map or the Google Maps of running the queries against the big data. But you can kind of see as that I'm gonna actually just extend my monitor so you can see them both, and then I can just walk through it right here. Let's see if this works. All right, is it up there? All right, perfect. So as you walk through this is just calling the top part's calling my AWS API, but literally, what is this, like 10 lines of code? And then I'm querying back, here's the Microsoft example. You get your CNAME, your A record. So even though I'm doing a heat map, you can see all the additional information that I pull back. And this is what's neat too, is you don't have to be a pro developer. You just work bits and pieces. So you can see what parts of your code are working. You can quickly look at variables, quickly look, what's my data look like step by step using this. So you walk through this, you see that I have this output. So what do I want to do with it? I want to go ahead down. These are just output. So I want to load. You can actually load new Jupyter notebooks. So what I'm running this is that web Jupyter notebook that I talked about earlier. I can call different ones. So in order to draw these heat maps, I don't want to recreate the wheel 100 times. We're talking about not doing that. So what I do is I create a notebook that actually just has a function, and all it does is it receives df hosts in there, which is my variable. So that's my data frame. So I'm passing it this big frame of all the data I just collected. It can have 100 columns, 1,000,000 rows. It doesn't matter. I wrote it so it would be interoperable. And then all I have to do is pass that function and tell which column has the IP address in there. And so as long as I can normalize whatever data from any tool, whether you use Nmap, you do scans, port scans, anything, as long as you put it into a data frame, which is about 3 lines of code, and then you tell it what column I'm going to share this code out that you can do. You pass it, you can do heat maps, you can do whatever you want off of it and continue the process. And the goal is just to iterate over it so it can be as reusable, functional as possible. And then you can build some counts so you can see how many different places, the different latitudes, longitudes. So this is just step by step, because I think it's hard to write programs that are extensive before you see, but just the speed at which you can work and iterate over 4 lines of code just to make sure you have it right and operating, it's just, I think it's really neat. And it does inline heat maps, so you can save it. This is Google Maps. I can switch to satellite view. You can zoom in. I mean, this is, since I'm not connected to the internet, it just lost the picture, but everything you do within a live Google Maps, it's real-time streaming, processing, talking out. You can do all this within a lab notebook. So if you picture what science in the future is going to look like, your white papers are no longer going to be these academic white papers you're reading. You are hopefully reading Jupyter notebooks and similar type things where it shows the actual algorithms being used, the analysis, and it's repeatable. This next time you read a research paper that has calculations and things in it, they should be delivering these in these notebooks, because then anybody can vet it. They can go through, you can validate actual proof, scientific proof that these are running, they're living, breathing. You can iterate on top of these. Other research can build in the community. So you deliver this, and also it maintains integrity, it maintains validity. You can version control it. You can see how things go. This is where science is heading, and I think it's really neat. But I think information security can play such a massive role in just leaps and bounds and being able to do that. So that's just the one example there. I'm not going to go much further, but what I'm going to share out, here's the certificate transparency code that we can do. In it, you go through and it does a lot of the same steps. The BSIM, so what I'm doing is, this is the application security measurement one, BSIM. All I do is I pull in an Excel spreadsheet. I mean, how much easier does it get than Pandas, which is the data frame tool, read_Excel, and then I just pass it in, and it automatically figures out the columns you want to use, and you figure out which ones you want and do. I mean, what's this? 4 lines of code, and I've now just imported an Excel spreadsheet into a data frame that I can do any analytics that I want on it. Pretty neat. This is why I like to stay up at night. I mean, just think of all the things that you could do with this. So, I mean, all in line, you can do that. I'll share that. Here's the CVE code. It took a couple, I had to do a little data validation there because they don't actually give you a creation date, but you can work through it. You show it. Here's, what is this, 150,000 CVEs you can process all within this few lines of code. You can do analytics, see. So I walked through, I want to do the counts. Here's by year. Here's what the actual data looks like in there. And then what I like to do too is I don't like to manipulate anything before it. So whatever source you get, you can download it directly off their website. You could actually do a wget at the top, just so you're always pulling the most recent data rather than saving it locally. But don't modify the data because you're going to have to do iterative work. Figure out how you download it, that exact format, work with that because you can. And then you don't have to do anything manually. You just literally click through, and you could pull all this into one and do it. But so there's that one. And then the bouquet plot that I showed with the CVs, you can actually plot it to a HTML page, and you can run whole Jupyter notebooks out of there. So one of the things I'd say, just to get started, there's a tool called Anaconda, and it has Jupyter built in. So you just go download Anaconda. It's free, open source, and you click one button, and it'll start up that Jupyter running notebook that you saw. It runs locally, and start iterating, start learning. And I hope this gives you some nuggets to expand on, and I will tweet out the link to the GitHub once I get it cleaned up and posted later this weekend. So keep an eye out for that. And I appreciate everyone coming. Thank you. We have a couple of minutes for questions, so feel free. I have a couple of minutes, or if you need, you can come up and talk to me after. So thank you. Yeah. So the question is, how did I secure some of these public instances? I mean, a lot of it actually comes down to securing websites. So it's access management, it's access control. If you're doing internet exposed, multi-factor authentication, you look at least privilege. So if you are going to be running locally on the host, you want to make sure you're running as least privilege. You need to do user profiles so you can't cross-pollinate across different ones. I mean, you look at it from layers, but it's very similar to securing a typical web page. There's nothing real creative, fancy about it other than just making sure the typical. Good question. All right, well, thank you, everyone. Oh, yes, question back. I will, absolutely. All right. There you go. At Ryan Elkins. Yes, another question? This is everything that I just showed you in that is running locally. And then some of the calls like the API, the Google Maps call, that's all cloud-based, typically using mostly free tiers. So I think this month I've done hundreds of queries and requests and I've spent about $5. So it's very affordable. All right, thank you.